These three intersecting lines form several angles. To find the measure of angle x, notice that the three intersecting lines also form a triangle. So if we can find the interior angles of this triangle, we can find the measure of angle x. To find the measure of this first angle up in the upper left-hand corner, notice that it is supplementary to the given angle. So to find the measure of this angle, all we have to do is subtract it from 180. You know, the sum of supplementary angles is always 180. So we have the measure of one of the interior angles of that triangle. Now if I go over to this second angle on the right side, notice that it's vertical to the given angle. Vertical angles are equal, so we now have two of the interior angles of a triangle. Well, the sum of the three angles of a triangle always add to 180. So to find this third angle, it's 180 minus the sum of the other two angles. So it gives me 93 degrees. Well, angle x is vertical to that third angle, so the measure of angle x is also 93 degrees because vertical angles are equal. I have, again, three intersecting lines forming several angles. We want to use the given angles to find the measure of angle x. So again, we notice that these three intersecting lines form a triangle. So if I can find the interior angles of this triangle, I can find the measure of angle x. Well, I already know the measure of one of the angles inside the triangle. If I go over to the left side, I see that this angle is vertical to a 30-degree angle, so it's also going to measure 30 degrees because vertical angles are equal. Now I know two of the interior angles of a triangle, and I know that the sum of three of the angles of a triangle always add up to 180. So to find this third angle, if I take 180 minus the sum of the angles that we already have, the 35 plus 30, I see that that third angle is 115 degrees. Well, that third angle is supplementary to angle x. So to find the measure of angle x, all I have to do is take 180 minus that third angle, the 115. The supplementary angles always add up to 180, so I get that third angle is 65 degrees. Now, in this problem we have two parallel lines, lines L1 and L2, cut by two transversals. I call one line 3 and line 4. Now this forms a lot of different angles. We want to use the given angles to find the rest of the angles. So if I start out with this angle here in the corner, this 50-degree angle, I notice that it's vertical to angle 4. So vertical angles are equal, so angle 4 is also going to be 50 degrees. Now angle 3 is supplementary to angle 4. They have to add up to 180. So 180 minus 50 is 130. Angle 3 is 130. The angle directly vertical to it is also 130. Now angle 2 is alternate interior inside the parallel lines, kind of on the diagonal. So their alternate interior and alternate interior angles are equal. So the measure of angle 2 is also 50 degrees. Well, once I know angle 2, I can also find angle 5 because they're vertical angles, and vertical angles are equal. Now, angle 6, I can do that pretty easily because it's vertical to the 40-degree angle. Again, vertical angles are equal. Now, angle 10 is the alternate interior to angle 6. That is, inside the parallel lines on opposite sides of the transversal, but not adjacent. Kind of on the diagonal. So 10 is 40. Well, if 10 is 40, then so is 12 because it's vertical to it. Well, 9 and 10 are supplementary. They form that straight line. So if I subtract that 40 from 180, I see that 9 is 140. And 11 is vertical to it, so that's also 140. Now I have 2 of the interior angles of a triangle. So to find angle 7, it would be 180, because the sum of the 3 angles in a triangle is 180 minus what we have so far. We have the 50 plus 40. So we get a total of 90 for angle 7. Well, once I know angle 7, I also know angle 1 because those angles are vertical.